Welcome to the Explainer. Look, today we're absolutely shattering some major cosmic illusions, going all the way from the Big Bang out to the dark flow. We're diving right into how brand new data from the James Webb Space Telescope, paired with some seriously advanced math, is aggressively proving that pretty much everything we thought we knew about the cosmos is completely wrong. For decades, we had this comfortable, static map of our universe. But recently, we've been hit with this overwhelming influx of raw, frankly impossible data that has just shattered those old ideas. So today, we're going to reconstruct our reality. We're looking at the absolute bleeding edge of astrophysics, the horrifying velocities of our own galactic neighborhood, and the stark mathematical probability of our very existence.
Let's kick things off by busting a myth you probably heard a million times. You know how people confidently proclaim that because light takes so long to reach us, the stars you're looking at in the night sky are already dead? Well, astrophysics paints a totally different picture. The stars visible to your naked eye are actually within a relatively close 4,000 light-years, and when you look at the stellar death rate in the Milky Way, which is roughly one visible star dying every 10,000 years, it means those twinkling lights in your backyard are almost certainly still alive and furiously burning. So our immediate neighborhood is actually comfortingly stable.
But that cozy, static, local perspective, it completely shatters the second we zoom out past our own galaxy. Which brings us to Illusion 1, 2 trillion hidden empires.
To really wrap our heads around the true scale of the universe, we have to grapple with something called cosmological redshift. As the fabric of space expands in every direction, it violently stretches the ancient light traveling through it, basically pushing those short, visible wavelengths deep into the invisible infrared spectrum. For decades, our textbooks confidently said there were maybe 1 to 200 billion galaxies. But that number came from the Hubble Space Telescope's deep field extrapolation in visible light. Hubble was essentially looking through a dusty keyhole, completely blind to deep infrared. Enter the James Webb Space Telescope. This machine was mathematically designed with immense golden mirrors specifically to pierce that cosmic dust, and it proved what theoretical models from 2016 were already hinting at. There aren't 200 billion galaxies. There are a terrifying 2 trillion hidden galactic empires drifting out there in the observable universe.
2 trillion. Just think about that for a second. To truly internalize a staggeringly vast number like that, we kind of have to abandon human metrics altogether. If you take the hundreds of billions of stars just in our own average Milky Way and multiply that by 2 trillion galaxies, you get hundreds of sextillions of violently burning stars. That's a 1 followed by 23 zeros. I mean, to put that into perspective, there are significantly more furiously burning stars scattered across the freezing void than there are individual grains of sand on every single beach, desert, and ocean floor on Earth combined. It's wild. And the universe is entirely indifferent to our struggle to even comprehend it.
But honestly, the sheer number of galaxies wasn't even the biggest shock. That brings us to Illusion 2, breaking the cosmic timeline.
We expected to look back and find this quiet cosmic dawn, right? Just slowly clumping hydrogen and helium gas. Instead, James Webb's deepest observations handed us a catastrophic chronological anomaly. It's a glitch that threatens to completely break the standard lambda-cold dark matter model of modern physics. See, precision measurements rigidly anchor the Big Bang at exactly 13.8 billion years ago. Yet, when Webb looked back 13.3 billion years, which is a mere 500 million years after creation, it did not find primitive baby galaxies. It found absolute cosmic monsters. We are observing fully mature billion solar mass black holes fully operating at a time where, mathematically speaking, they have absolutely no right to exist.
So why does this fundamentally break our physics? Well, standard black holes are born from collapsed stars, these tiny seeds that grow by pulling in gas. But their growth speed is strictly restricted by something called the Eddington limit. It's this self-regulating thermodynamic mechanism where inward gravity fights outward radiation pressure in this massive cosmic tug-of-war. If a black hole feeds too fast, the outward radiation pressure violently blows its fuel away. Even if we invoke some really exotic theoretical loopholes, like super Eddington accretion or the direct uniform collapse of massive hydrogen clouds that just bypass the star phase entirely, the math still fails. The primordial universe simply did not provide enough time by hundreds of millions of years for these massive singularities to grow from standard stellar seeds.
Because of this impossible timeline crisis, we're forced to look at radical alternatives that basically rewrite our entire understanding of reality. Take Nobel laureate Sir Roger Penrose, for example. He theorized conformal cyclic cosmology, proposing that the universe actually goes through endless cycles of death and rebirth. When an old universe dies in a heat death, its finally evaporating supermassive black holes leave concentrated thermal scars on the fabric of the next Big Bang. These are called Hawking points. So if Penrose is right, these impossible early black holes Webb is seeing, they are inherited architecture. They're literally the resurrected ghosts of a previous universe that physically passed through the Big Bang into ours.
Okay, if cyclic universes and dead realities aren't enough existential dread for you, let's look closer to home with Illusion 3, the static neighborhood.
We kind of feel like we're just peacefully drifting along, right? Well, the comfortable illusion of our stationary Milky Way is completely false. By measuring the dipole anisotropy, which is a distinct thermal shift in the cosmic microwave background, astrophysicists discovered the ultimate universal speedometer, and it definitively proves that our entire local galactic neighborhood is not drifting peacefully at all. We are actually in a catastrophic gravitational freefall, plunging blindly through the freezing intergalactic vacuum at an incomprehensible 2.2 million kilometers per hour.
Now, gravity doesn't just pull for no reason. It needs a massive physical source. We are accelerating towards something unimaginably heavy. But what makes this freefall absolutely terrifying is our exact trajectory. We are being pulled directly into the thickest part of the zone of avoidance. This is a massive band of dense dust and unignited gas right along our own galaxy's equator. And it physically absorbs visible light, totally blinding us to 20% of the distant observable sky. So we are essentially accelerating wildly out of control in a vehicle with a completely painted-over windshield.
By finally using infrared and X-ray frequencies to pierce through that dust, astronomers uncovered this inescapable hierarchy of cosmic power. It's like giant cosmic Russian nesting dolls. First, our local group is just this microscopic rural suburb falling toward the Virgo cluster. But Virgo itself is falling toward a massive gravitational basin called the Great Attractor. And guess what? The Great Attractor is just the bottom of the Laniakea watershed, which is actively being hauled bodily across the void by the monumental Shapley supercluster. It's a relentless cascade where every structure is subjugated by a heavier master.
But wait, even the Shapley supercluster isn't the final boss of our reality. The residual velocities of all these galaxy clusters point to a massive anomaly known as the dark flow. This data definitively proves we are being tugged by incomprehensibly massive structures that reside permanently beyond the boundaries of light itself. Our visible reality is literally tilting toward an unseen, unfathomable mass located entirely outside our observable cosmological horizon.
Surrounded by an infinite expanding dark populated by 2 trillion galaxies and incomprehensible gravitational monsters, we naturally turn the math back toward ourselves. Here is Illusion 4, Human Uniqueness.
In a universe this unfathomably vast and aggressively dynamic, what is the statistical reality of our own existence? Astrophysicists Adam Frank and Woodruff Sullivan decided to revise the famous Drake equation. They wanted to strip away all the uncertainties about how long a civilization might last. Instead, they shifted the focus to a cosmic archaeological question. Rather than asking how many civilizations may exist right now, they asked, are we the only technological species that has ever arisen? By framing it exactly this way, they were able to calculate exactly how unlikely advanced life must be for humanity to be a unique statistical anomaly.
They established a strict pessimism line. For humanity to be the sole technological civilization to have ever existed across the entire history of the cosmos, the odds of a civilization evolving on a habitable planet must be less than 1 in 10 billion trillion. Yeah, that's 10 billion trillion. As Adam Frank pointed out, that number is incredibly, absurdly small. If the actual probability of life forming is even slightly greater than this pessimism line, then advanced technological species have very likely happened before us.
And when we look at the raw data from the Kepler Space Telescope, we know that roughly 1/5 of stars host planets in habitable zones. Apply that to the 20 billion trillion stars in the observable universe, and the sheer cosmic real estate is staggering. While astrophysics is a strict discipline of observation, it is astonishingly mathematically likely that advanced civilizations have evolved billions of times before us over cosmic history. So instead of feeling isolated, we should really feel empowered knowing we are part of an incredibly grand cosmic lineage. Our evolution is highly, highly unlikely to be unique.
Every single time humanity has boldly claimed to have finally measured the boundaries of our reality, the universe has profoundly humiliated our confidence. We are constantly having to redraw the maps of an indifferent cosmos. We've gone from thinking we're an isolated island of light to realizing we're in a turbulent ocean of 2 trillion galaxies, driven by invisible mass and ancient ghosts. As our technological eyes open wider, the most thrilling, and let's face it, terrifying question remains. What else is patiently waiting for us out there in the dark?